Okay, guys, let's look at the ACT prep questions. So we got a couple here, which mimic kind of carefully the ones we did for prep for the future last week. Okay. And they mimic in the sense that we have to kind of have a good sense of how numbers come together in series and sequences. So this one says the average of 5 numbers is 20. What is the sum of those numbers? And so if we approach this by just kind of understanding how to take an average, which is a measure of central tendency, we can do two things. One, we can knock out some answers that just no way could be right, and then we can actually solve for the one that has to be right. And so my claim right off the bat is that we know the average has to be 20. These three answers cannot be the right answer right now. Um, average is a measure of central tendency, so it's kind of like the number that's in the middle of the numbers. And if the average is 20, then the sums cannot be less than 20. This is going to be impossible. So these three are probably going to be out. For the same reason, I suspect 25 is not a good answer either, and the answer is probably going to be 100, but let's confirm that by just understanding what average means. So for example, if you took an average of like 4 numbers, so like 4, 10, 15, and 6, think about how you take that average. Well, you do two things. One, you add them together. You take 4 plus 10 plus 15 plus 6, which would be, you'll see 10, 20, 35. Okay, and then you take that 35 and you divide it by 4 because that's how you take the average. And then you get whatever that ends up being, which would be like what? Like 8, 32, 3, so 8.75, I think. Okay, and so if you think about what you just told yourself, two things are going to happen. One, you're going to take the sum of the numbers, which in this case was 35, and then you're going to divide it by how many numbers you have. Let's just call it n for now, which in this upper example was 4, and that's what you're going to call the average. Well, you have most of those numbers in your problem. So one, you're told the average of this problem is 20, so we can substitute 20 in for the average. You're told there are 5 numbers in this problem. It's right up here. But you don't know this value, which I'm just going to call x. But if you look at the equation you set up, that's a pretty easy equation to solve. We can just multiply both sides by 5. And so x in this case will just be 100. And so 25 seemed pretty low, but we can confirm 100 is indeed the answer if we just examine what we know about average. And this is really what algebra is all about. Generalizing relationship and then using it to solve another problem. Now this one does have a typo, which I'll try and announce in class next time. This shouldn't say there, this should actually say 3. Whoa. Okay, like I said, it shouldn't say there, this should say 3. Okay, and so if you look at this, this is a classic choice web kind of problem. So they're really asking like combinations. Now there's a shortcut to this kind of problem, but I want to take you through the big web first so you can kind of use it to understand how you can apply this thought in the future. So if you simplify the problem, we basically have 3 categories. We have 3 different colors, and then we have 2 laces, and then we have this crazy thing at the end, which is logos, and we have 8 of those, which is really going to throw our numbers off. I'm gonna see. I'm gonna guess the answer is going to be 48. And let's see if we can see why the answer is going to be 48. And so what we should do is first kind of label out what we have. So we have 3 different colors. I'll call them 1C, 2C, 3C. And then we have 2 different laces, so 1L, 2L, and then we have 8 different kind of logos. I'll go 1G, because I get rid of use L, 2G, 3G, 4G, which is the best kind of coverage, right? 5G, 6, 7, and 8G. Okay. Now, what we could do if we were in a pinch is to actually like draw lines, but we're going to draw enough lines so we kind of get a sense how to shortcut the counting structure here. And so we can just start making choices. So let's say we chose 1C. Well, if I choose 1C, the first color, I can actually choose 2 different types of laces. Okay? If I chose 2, I can also choose different laces. And if I chose color 3, again, I can make a choice of 2 different laces. And so right here, this reveals that I actually have 6 different things I could choose within the first 2 columns of my choice structure. Because I have each of these 3 things give me 2 different choices. So 3 things at 2 choices each make a total of 6 choices. If we bump that up one more level, if I choose 1C, 1L, I could choose, and here's where it's going to get messy, but we're not going to do the whole thing anyway. I can choose 8 different things right here. And then I can also do the same thing With this guy, I can choose 8. Okay, and so this tells me that for every one of my 6 choices, I could make additional 8 choices at the next between the next 2 columns. Well, if the first 2 inform 6 choices, the last 2 inform 8, that should make a total of 48 different choices. And I could actually literally count that out. Like I could take each one of these strings and trace them, say, in a different color, which I don't have anywhere near 48 different colors. But like that, ooh, way too big. So this would be choice 1. This would be choice 2, choice 3, choice 4, and so on and so on. But once we realize that we just have 2 of 3 choices, giving us 2 different choices in the middle, giving us 8 choices at the end, we can quickly gain 48 by just simply realizing that the number of choices should be 3 for the first, 2 for the second, and 8 for the third, which would be 6 times 8, and of course 48, which we predicted at the beginning. And so this is the important thing to note here is that each choice is different and you can't repeat the choices, which is why we can actually use this type of counting structure to find it. Okay, so just a little word to the wise about how to choose or come up with different kind of combinations when the choice order does indeed matter. Okay, so that's all for ACT prep. We have one more to do, which is the rational function.